Welcome back to Cyberx Innovations. Today, we're diving deep into the fascinating world of cloud computing. Cloud computing refers to the delivery of various computing services, including storage, processing power, networking, databases, software, and more, over the internet. Instead of owning and managing physical hardware and software infrastructure, organizations and individuals can access and use these resources on a pay-as-you-go basis from cloud service providers. Key characteristics of cloud computing include: firstly, on-demand self-service. Users can provision and manage computing resources as needed, without requiring human intervention from the service provider. Secondly, broad network access. Cloud services are accessible over the internet from a variety of devices, such as laptops, smartphones, and tablets. Furthermore, resource pooling. Cloud providers use multi-tenant models, where multiple users share the same physical resources. These resources are dynamically allocated and reassigned based on demand. Rapid elasticity. Users can quickly scale up or down their cloud resources to accommodate changes in workload or demand. This elasticity helps optimize cost and performance. Measured service. Cloud computing resources are metered, and users are billed based on their actual usage. This pay-as-you-go model can be cost-effective because users only pay for what they use. Cloud services encompass a wide range of on-demand computing resources and applications that are delivered over the internet by cloud service providers. These services are typically categorized into three main service models: Infrastructure as a Service, IaaS, Platform as a Service, PaaS, and Software as a Service, SaaS. Here are examples of each type of cloud service. Infrastructure as a Service, IaaS. IaaS provides users with virtualized computing resources over the internet. Users can manage and control these resources, including virtual machines, storage, and networking components. Some examples of IaaS providers and services include: Amazon Web Services, AWS, EC2, offers scalable virtual machines. Microsoft Azure Virtual Machines provides a variety of VM options. Google Cloud Compute Engine offers customizable VMs. DigitalOcean, known for its developer-friendly cloud infrastructure. Platform as a Service, PaaS. PaaS offers a platform and environment for developers to build, deploy, and manage applications without worrying about the underlying infrastructure. Some PaaS offerings and providers include: Heroku, a fully managed platform for building and deploying web applications. Google App Engine, a platform for building and deploying applications using various programming languages. Microsoft Azure App Service, a platform for building web and mobile apps. Red Hat OpenShift, an enterprise Kubernetes platform for containerized applications. Software as a Service, SaaS. SaaS delivers software applications over the internet on a subscription basis. Users can access these applications through web browsers without the need for installation or maintenance. Examples of SaaS products include: Microsoft 365, formerly Office 365, provides cloud-based productivity and collaboration tools. Salesforce offers customer relationship management, CRM, software as a service. Google Workspace, formerly G Suite, provides email, document collaboration, and communication tools. Dropbox offers cloud-based file storage and collaboration. In addition to these three primary service models, there are also specialized cloud services known as Function as a Service, FaaS, or serverless computing, which allow developers to run code in response to specific events without managing servers. Examples of FaaS providers include AWS Lambda, Azure Functions, and Google Cloud Functions. Hypervisor in cloud. In cloud computing, a hypervisor, also known as a virtual machine monitor, VMM, plays a crucial role in the virtualization of physical hardware resources. Hypervisors are software or firmware layers that enable the creation and management of virtual machines, VMS, on a physical server. They allow multiple VMS, each running its own operating system and applications, to coexist on the same physical hardware. Types of hypervisors. There are two main types of hypervisors: Type 1, bare metal, and Type 2, hosted. Type 1 hypervisors run directly on the physical hardware without the need for an underlying operating system. Examples include VMware vSphere/ES11, Microsoft Hyper-V, and Xen. Type 2 hypervisors run on top of an existing operating system and are typically used for development or testing purposes. Examples include Oracle VirtualBox and VMware Workstation. Cloud deployment models. Cloud deployment models refer to the different ways in which cloud computing resources and services can be deployed to meet the needs of organizations or individuals. There are primarily four common cloud deployment models. Public cloud. In a public cloud deployment, cloud services and resources are owned and operated by third-party cloud service providers. These providers make their computing resources, such as servers, storage, and networking, available to the public over the Internet. Public cloud services are typically offered on a pay-as-you-go basis, and users can access them through web interfaces or APIs. Examples of public cloud providers include Amazon Web Services, AWS, Microsoft Azure, Google Cloud Platform, GCP, and IBM Cloud. Private cloud. A private cloud is a cloud infrastructure that is dedicated to a single organization. It can be hosted on premises, on the organization's own hardware and data centers, or by a third-party provider. Private clouds offer greater control, security, and customization compared to public clouds. They are often used by organizations with specific regulatory or compliance requirements or those that need maximum control over their infrastructure. Hybrid cloud. Hybrid cloud combines elements of both public and private cloud deployments. It allows data and applications to be shared between them, providing greater flexibility and scalability. Organizations can choose to run certain workloads in their private cloud while using public cloud resources for others. Hybrid cloud deployments are beneficial when organizations want to leverage the advantages of both public and private clouds. Multi-cloud. A multi-cloud deployment involves using services and resources from multiple cloud providers. Organizations may choose different cloud providers for specific tasks or services to optimize costs, performance, or functionality. The goal is to avoid vendor lock-in and take advantage of the strengths of various cloud providers. Managing a multi-cloud environment can be complex, requiring effective cloud management and orchestration tools. Each deployment model has its own set of advantages and considerations, and the choice of the deployment model depends on an organization's specific requirements, such as data security, scalability, cost-effectiveness, and regulatory compliance. Many organizations also adopt a mix of these deployment models to meet their diverse needs. Pay-as-you-go from CapEx to OpEx. The shift from capital expenditures, CapEx, to operating expenses, OpEx, is a significant benefit that many organizations experience when adopting cloud computing services, particularly those provided by public cloud providers. This transition has several implications. It's important to note that while the shift to OpEx has numerous advantages, organizations should carefully monitor their cloud spending to avoid unnecessary costs. Effective cloud cost management involves optimizing resource usage, selecting appropriate pricing models, and implementing governance policies to control expenses. Overall, the move from CapEx to OpEx in cloud computing can result in greater financial flexibility, operational agility, and a more efficient use of resources for many organizations. Thank you for watching this video. Make sure to like, subscribe and comment. Follow us on Instagram at Cyberx Innovations for more content.